Okay, good evening, everybody. Welcome to the teaching C++ workshop teaching panel. And we'll be starting off by having each one of you introduce yourself, tell me where do you teach, and if you can, a few words about the C++ course that you teach. Is it required or an elective? And what is the background of the students that reach the C++ course? What year they study, semester, and what other programming languages they learned before.
Okay, my name is Adina Milstone. I teach in the Academic Life Center in the Girls' College in Machon Tal in Jerusalem, right? It's the girls' campus of the Live Academic Center. I teach two main C++ courses and another one that uses C++ as the programming language. So the first one is the introductory Mavole Madei HaMachshev, the introductory course, and that's mandatory. The next one is called Sadna in C++. It's really the second course. It's also mandatory, the second semester of the first year. And the third course I teach is data structures. And they use C++ as the programming language for the exercises, and it's another experience for the students to use C++ again. It's also mandatory. The students who come there are from various backgrounds. Some have done Bagruyot, and there they learn various programming languages, and some come with no knowledge, and they have to take an introductory course before they start their C++ course.
And Adina, I want to ask something. In the first introductory course, you teach C++ with objects and everything, or just
no? We really teach C.
No, you teach C.
We really teach C++, but we only teach the C parts of it.
Okay.
Hi, my name is Michal Al-Khanati. I teach at Hadassah College, Jerusalem. I teach object-oriented programming using C++. It's a full year studies. After first year of C, and then third year is Java, also a full year. So it's 3 years of programming, each year different language. We also combine game development in the course to make it more pleasurable, enjoyable. Okay, thanks.
My name is Yechiel Kimchi. I teach at the Technion at the Computer Science faculty, and lately I started teaching also at Ort Braude. I teach mainly basic courses, programming courses. The first course is in C at both of them. Second course is half advanced C and C++, mandatory. At Ort Braude, C++ comes a little bit later. At the Technion, also C++ is introduced, is met by the students at advanced programming languages, and those who specialized in software engineering also take object-oriented programming, where C++ is the main language, but not the only one. That it is, mainly the idea is that students should know the ins and outs of how the computer works.
Hi, I'm Amir Kirsch. I teach object-oriented and C++ programming here at the Academic College of Tel Aviv-Yafo, and another course that also uses C++ called Advanced Programming in Tel Aviv University. The course here in the Academic College of Tel Aviv-Yafo is second year, first semester, so it is the third semester of studies. They learn before that C in their first year. It is a mandatory course, so they leave us, all the students, knowing good level of C++. At Tel Aviv University, it was a mandatory course for software engineering till the last semester. So I used to have about 120 students per semester, and after the course became elective, it dropped to about 50.
Hi, my name is Meir. I also teach at the Academic Center of Lev Academic Center. I teach also in the Lev Academic Center is a bit of a unique institution in Israel, is that we have separate campuses according to gender because of the target population, which are religious Orthodox Jews. So we have separate campuses for the different genders. I teach also by the men and also by the women. I'll just add on two things that to Adina. We teach our Introduction to Computer Science course in first semester. It's a 3-hour lecture course with 2 hours of lab or recitation. Then we have the workshop in C++, and that's where they first learn objects. In the first semester, basically we're teaching C with a flavor of C++, but it's printf, scanf, C in, C out, but we're teaching C. Also new and delete and not malloc. But basically we're teaching that, and in the second semester they have a 3-hour course called the workshop in C++. That's where they're learning the objects. In parallel to that, they learn their first data structure course. And there they learn and they write in pseudocode. What Adina mentioned about data structures is the data structures 2, which they do in second year, first semester. And there they're applying more advanced data structures, and they're implementing in C++, and that's where they really hit the maps and the templates and STL really hard. So that's for now.
Okay, so now I want to start with the major question that I think it's basic and interesting to us all, is why C++? Obviously, there are many, many other high-level languages by now. So what is the reason C++ is taught in your institution? And maybe the status of it changed over the years, or maybe there were thoughts or attempts of changing the status over the years? Anyone who wants to answer, feel free to answer.
Okay, so I will start. Here at the Academic College of Tel Aviv Yafo, as I said, it is a mandatory course. There were talks along the years, thoughts and talks about considering other options like C#, like Java, but usually I just convince them that let's stick with C++. And I have a few reasons for that. First of all, our graduates, many of them find actual jobs in the C++ industry. So if it works, don't break it. And I also believe that learning C++, you become a better programmer. So you know the under the hood. There is a post by Joel Spolsky, if you heard about him, the guy behind Stack Overflow, the perils of the Java schools, how the institutions went to Java, and Java is not something bad. Eventually you can program in Java, and many of our graduates do that, but it will, two things will happen. First, it will make it harder to pick the good ones, because you know one is a good programmer if he is good at C++. This is the argument, I believe in it. And also you make him better. So this is at least my belief, and this is why I urge to stick with C++. And I think that while other institutions go for other options, it even make it more important to stick to C++, because then you have less C++ developers at the market, which brings some more advantage to those who do know C++. So they can ask for better salaries. And that's important. In Tel Aviv University, I was starting with a mandatory course, and things changed there. When I started there, they were teaching C and then C++, and this was the path. They started with Scheme. Nobody in the industry will program in Scheme, but this is just, to start with some functional programming, and then C and C++. And today it is Python and Java, and like what Joel says. But they do come, some of them, to the C++ course.
I'm interested to know, do you keep contact with some of the students here after they graduate? Maybe you can ask them how do they see it in perspective? Do they feel blessed that they learn C++? Do you get any objections?
Well, some of them sit in the audience, I think.
We can ask them.
Yeah, we can ask them later. Daniel, what do you say? It is good to learn C++, or?
Did it help you?
Personally, I was writing C++ before I started my studies, so I'm not very best example for that. But I think that since it's the basis for every for the concept of programming that I see, it's crucial for someone to at least have a basic knowledge about those languages. Because without, I don't think you can really understand any other language properly.
I would just repeat shortly for the recording. So Daniel says that my course was great and he enjoyed it very much. And that C and C++ are important for learning other languages, and that he knew already C, or he came from C when he came here. And maybe you chose the Academic College of Tel Aviv because you knew C and you picked some institution that, give honor to C and C++, might be. But I do meet our graduates, and they are in the industry, and I think that in a way they appreciate the knowledge that they got in the language.
Okay, thank you. Anybody else care to?
First, I want to comment about choosing an institution with C for those students who have prior knowledge. So at least at the Technion, almost 20 years ago, the TAs made statistics, and what they found was that during the first 4 homeworks, the worst homeworks were by those who used parts of C that we didn't teach yet. So prior knowledge does not guarantee good knowledge, at least. And this is generally, at least in my view, is a general problem that in many cases people don't learn the languages, especially C and C++ in some sense, are easy to learn wrongly. It is used to say in C that it is very easy for the programmer to shoot oneself in the foot. And Bjorn Straustrup admitted that he once said that in C++ it's harder for the programmer to shoot oneself in the foot, but when he succeeds, he blows the whole leg off. So good teaching is a problem. I'm not involved in decisions of the Technion, but when students ask me why not teaching Java, I said, if you know C++, it's easy to learn Java. If you know Java, learning C++ is just from the beginning.
That's true. I agree.
The question is, what is also the FPL, the first programming language? We're an institution, sitting in the Faculty of Engineering. So we also have software engineering, electrical engineering, physics engineering. So, and it's a common course for everybody. So one of the reasons that we're into C as a first language, C, C++, is because it's part of the engineering faculty. And that's an important element because they need to be able to go into embedded systems and know that type of knowledge base. Also, there's the main question in education, in computer science education, is objects first or not. It's a big dialogue that's been going on for the last 20 years. And you can find people that will say this and people will say that. And it's a big question. And definitely by us, because of the institutional things of the engineering, we are definitely going on the paradigm of procedural languages first, And then after you have a basis in the procedural language, then you go over to the object-oriented. And therefore, C, C++ is a correct answer to do that.
You already said everything.
Same.
No, come on.
Okay, as I'll just add one or two things. Just we have this discussion. We just had discussion now in the break among us. We all, Meir and Joyce and Chani and myself, we sit together and we prepare this course again and again. And Chani and Joyce work very hard on this course. And the question is really if we should continue teaching C++ because it looks like maybe it's passé, maybe people don't use it anymore. So here we hear in the audience, and we spoke to you also in the break that it's not, that we should continue, right?
Well, like I said yesterday, eventually you need to choose the right language for what you do. So not always C++ would be the right tool. But in some places, I believe that at least from the moment point of view, C and or C++ remain always in some issues at least. For example, in airborne systems, and also if you need the very last bit of optimization, like we heard on the other session on high-frequency trading and in gaming. So wherever you need to take the most of the performance, that will probably remain, and also in where safety and reliability are a big issue. Well, I don't know, but from what I see now, this is still remain there.
I feel the same as a teacher. If I'm thinking about educating the next generation of programmers, I feel that really C++ has the foundations of all the languages in a good way, because I also teach Java, I also teach C#, and I also, at the third year, I also teach a course called Principle of Programming Languages, and we come back and back to the same principles that we learn in C++. So
You get
I don't
any
know.
objections from your students, or maybe they like it, like
the
you?
students are just busy surviving in their first
Really?
year. So they're-
Maybe I'll just add one sentence.
Yes.
Starting with C and C++ is a bit like working with a hammer and a chisel. And this is why it feels right.
Okay.
First of all, I like and I used your analogy with the hammer and chisel, but this I will save for the lecture, the presentation I will do tomorrow. And I see that I somehow, I differ. I will talk about C++ as first language, and I teach it completely different than just C and C in, with C in and C out. I think it can be done differently.
Okay, you start with objects and everything.
Not really, but I start with object, but not the way you think.
Okay, we'll wait
I'm
for
sorry.
tomorrow lecture. No problem. Yeah, we will come. Okay, so let's talk about teaching C++ while you're teaching C++ versus teaching C when you're teaching C++ in the light of the Kate Gregory talk. Stop teaching C, the famous talk. So I want to know what's your opinion about teaching first row pointers or maybe smart pointers, teaching char pointers, or maybe start with pseudo vectors, etc.
Okay, so I do go through pointers, but it is mainly the students come to my course after they learn C already, so they know pointers. And I start with classes and with object-oriented part. So in a way, I'm doing it bottom up and not exactly as Kate Gregory in the Stop Teaching C when you're teaching C++ would recommend. I do, my path is to go to, at the end, to the rule of zero, to use in your classes vectors and string and smart pointers, and do not manage your resources inside. Use other classes to manage your resources, and especially existing classes from the standard library, but I reach it gradually. And as I already mentioned in my lecture previously today, when we do reach smart pointers and the students realize that we may say goodbye to pointers, they are very happy, but then they see that we do not say goodbye to pointers and that smart pointers are their own very complex creature, and now they have to know both. So I think that at the end, they should know both, and this is what I'm striving at.
I'm going to throw you another curveball. We have a problem that in high schools, they learn programming, and there's more and more students that come with some type of programming experience, either formal or informal. And they basically learn usually Java, C Sharp, right. I know from the high school curriculum and everything. So what happens is that a lot of students come and think, oh, it's going to be an easy course. So in the first few weeks, they have it easy until they see star. They see the kochavit, the star, and then they realize that some of the other people that had no previous experience maybe have a better chance than them. And then we can really see who are the students who, just because of prior knowledge, they're doing well, or they're good students. And that's that's just a byproduct of the C++ issue. It's a byproduct. But definitely when you're talking about, just like with lists, let's take data structures, you take a linked list. There's two different ways of teaching it. I can just give it to you, let's play with it and use it and whatever. Or I can say, okay, this is how it works. Let's implement, insert, and delete, and do all the things. And then, yes, this language gives you those tools to be able to do it. The bottom-up approach, and then they understand what's under the hood. And also you're, by the way, also doing a lot of, your practice, the student is really working and coding, and I just get an extra advantage out of that, and he understands what's going on, and not just using something, there's an expression in Hebrew, to use what's already, I want them to build it themselves as well. And then afterwards, they can use existing tools. I know that maybe somebody doesn't agree.
Okay. So let's move on to speak a little bit about the C++ features. What features you think are must and you must teach? Perhaps there are features you hate or hate teaching, and you teach only because you have to. I have a few examples here, maybe auto, maybe namespaces, smart pointers, containers, algorithm, function objects, template, including specialization, maybe variety templates, compilation process, whatever you want to talk about.
Because we have a whole year for C++ programming, we have the privilege of teaching almost all these subjects. I'm not trying to go into very fine details. It's more important for me to speak about ideas, concepts, and the students can read by themselves more and more details. Also, Yechezkel is part of the team, the teaching team, so there's someone that knows every new element.
C++ 20.
Yes.
So we only have one course, one semester for it, so it's not enough to teach all the features. And also today I realized how much I don't know about all the new features. But I think it depends what your goal is, what's your aim. So if we're trying to educate the next programmers and we have one course for C++, that's a workshop, after they had the basic course of the C, and now I want them to understand inheritance and polymorphism, and so I emphasize on that. And then the rest of the things are just however as much time as I have, I'll teach more things. But to teach more and more and more and more just because it's there, I don't think there's any point. Because at the end of the day, there'll always be new features, and they'll have to learn when they work and they work in the field. So that's what I think.
When I teach C++, at least at the Technion, it is half a semester, as I said before. Now, for both C and C++, I say at first that my lectures are just an introduction for reading good books, and the emphasis is on good, because there are so many bad of them. Anyway, in the exam, actually, I expect them to be able to write a class, to implement a class the right way, and many fail. And although I teach some advanced C++ features, they are just in the sense of teasers. And the difficulties of teaching C++ is C before that, because they have to unlearn so many features.
Wow.
But I do not agree that we should skip pointers, etc., because in one discussion group of the Association of C and C++ group, someone says, well, we don't need pointers anymore. And I said, but who will implement the next generation of STL? So they should know quite a lot, but the basics is still the challenge.
Regarding the features that you don't have time and you only give them teasers, you think the curious students bite on the teaser and go and learn them by themselves?
Some do. Some do, and some hate me. I don't mind.
Legitimate.
There is a principle in software engineering, mainly coming from UI, I think, the principle of least astonishment. And it relates to this question because my goal is that if they would work in C++ and they go to actual coding field, they will, in a way, experience the least astonishment. So I try to learn them anything that when they will see a program, they would not say, hey, we didn't learn that. And it means that anything that there are chances in a way that they will meet, I think that they need to meet in the course, even if I do not invest too much time in that. There are other things that even if they see, they can learn by themselves. There was a discussion lately in the SG20 group, the ISO CPP work group on education, which this workshop is in a way some of this effort, related to this effort, and we have Chris DiBiela as part of the organizing team of this workshop. He's not here today with us, and he's leading the SG20, and there was a discussion there on teaching character encoding. And there were many teachers who said that this is very important, character encoding. You cannot teach string without talking about UTF and encoding. And my view on that is that they should go and learn that on themselves if it is relevant to their code. Because, you know, chances that might not be relevant at all. And, you know, they can just go with char, simple char. So I do invest in things that I think they will, most chances will see in the field.
Somebody wants to ask you a question.
I would like to comment on this. That, first, I agree with you, but maybe you would like to mention like something advanced. If you want to go further, you might read about Unicode and UTF just for enrichment or something, like teasing them with this, even though it's not part of the material.
Yeah, so the idea of teasing them is something that we teachers do all the time, and then again we need to, if we spend an hour of teasing at the end of each lesson, it's too much. So we need even that to choose to pick our teasing, So we are teasing about, okay, there is the STD thread, maybe we did a small example, but there is more. So we have a lot to tease about, okay? And character encoding is not in the list of my teasings. Yeah. So yeah, I think it is somewhere there, but the summer where they do not go probably, and there are literal operator and many other more.
I think it's important, the main importance is for a student to know that there's new versions. First of all, there's a lot of different versions, and things get changed, and they have to see it being changed. And a lot of times I'll say, oh, this was in 98, this was in 11. Also, that students have to differentiate between the IDE, we were used with the Visual Studio, so they think, oh, Visual 2013, that's C++ 13, or C++, the Visual 2015 is C++. They have to understand those basic things, but they have to understand things change. That, for example, you can do, let's say I have a identifier, a bool, B. You can do B++, plus B. We all know that, up to C++ 14. In C++ 14, that's already, it's gone out already. Right? Things change. And they have to be aware that also the lecturer doesn't know about all the changes. So if a student comes up and says, oh, you know that's great, because then he went and did it. The idea is to give them the teasers, and I really agree about the teasers. They have to know the main concepts. We don't have time to show them how to do it at the end. That's a skill. That can be taught. You pick it up if you're going to be working in C++. We're talking about first year students. Until they finish in third year or fourth year, if it's an engineering degree, the flavor of the month will be D or E or F, whatever language will be. But they need to learn the concepts. We're teaching in a computer science degree. The question is, again, are we teaching, I'll put it in a different format, are we teaching problem solving or writing to specifications? If you want to look at it that way a bit. And it's a question. And that's something that that we're dealing with all the time, because the students are very practically orientated. Is this going to help me? First of all, is it on the exam? And then secondly, is it going to help me when I get out to the work? If it's not, I'm not interested. Just reference calculus, differential equations. Yes.
I would add something more, which is not related only to C++, but is important both for students, and I see it in the field as well. But students tend to come and say, it doesn't work for me. It doesn't work. And I teach them to elaborate. Doesn't work means didn't compile. It runs but doesn't provide the expected output. It crashes. And then they think that they don't have the answer. And I also teach them to read the compilation error, because when there are compilation errors, they go and fix the code. And then I'm asking, what are you doing? Because we have a lab, and some of the labs I pass, I teach them, and I see that they do not read the compilation error before going to fix the code. So we do that together, and then we go to Stack Overflow or to Google, and we start to analyze and understand what was the error before fixing it. I think it's important.
Okay, let's move on to discuss the level of knowledge and understanding of the students. It's a broad question, so just feel free to share your teaching targets regarding that understanding and knowledge level. What's the level of understanding and knowledge you expect from the students by the end of the course?
Okay, I've said before that after the first course of C++, not as first language though, it's different, but as a second language, which is the common practice these days, I expect them to know how to write a good class. One good class. Many of them are surprised when they get in the exam, they get points reduced because they had to implement plus operator, overloading, but they didn't implement a plus equal. And this is basics, in my view at least. And so this is the thing. The other thing is when I said about reading books after the lecture, is understanding, in some sense, the spirit of the language, its ideology, its strategy of the language, and I call it the spirit. And regarding the hammer and chisel, in one conversation with a lecturer at the Technion that I appreciate a lot and learned from him about teaching a lot, but we had disagreements on many points. He said, well, software engineers just want to organize things, but they don't solve the problem. They forget that programming is just a tool. And I told him, and it was like 15 years ago, I said, I agree with you that programming is a tool, but you think of it as the hammer and the chisel of the plumber. Break the wall, fix the leak, and put the plaster. And I think of it as the hammer and the chisel of the sculpture. If you don't do it right, you will break the marble.
Again, we teach a first-year course. So the first course, which is really C, is we just basically want them to first learn the language. And I think by the second course, we really expect them to already not be afraid of facing a problem and having a way to solve it in the object-oriented programming. But that's what I think, what we expect from them, more or less. We're still guiding them. Every exercise still guides them how to break up the classes, but I think that's where we're going towards.
Since we wrap our course with games, so we are very happy to see in the end that they manage with developing a whole simple computer game. It means definitions, requirements, choosing the right data structures, the algorithms, libraries, code, designing, testing, and of course playing. This is what we would like to see at the end of the course. Yes.
So it relates in a way to the grading or what I'm looking, I mean, in a more technical way. In my course, both at the Academic College of Tel Aviv-Yafo and then in Tel Aviv University, I have an exam which is a multiple choice questions where they have to read code and answer questions. And for that, they need to be able to read complex C++ code, which is important. And that's all. In the past, I gave them also time to write code, and I saw that there isn't enough time during the exam to write proper code. So there are some very fast students, but most of them do not. I can give them 10 hours, but I don't have. Doesn't seem reasonable. So I do give them ongoing project during the semester where they have to write code, object-oriented code in proper C++. And I also like games. So for example, do you know Thunderbird? There was a very old game, Thunderbird, a small spaceship and a bigger spaceship who need to travel the way inside, I think it is Egyptian pyramids. So they do that in a console screen, and it's great because they invent the screens, and from one screen they go to the next screen, and they are very enthusiastic about games, and it's a complicated object-oriented task. I like it.
We teach, the name of the course is Introduction to Computer Science. It's not Introduction to Programming. I think that's part of the answer. We want to teach the students computer science, algorithmics, problem solving. That's what they need. The vehicle is the language. So We want them to be able to use the language. So in Talmudic literature, there's an expression, hafochba kikuloba. In English, I even translated it, turn it and turn about it, turn it and turn about in it, for everything is in it. Just go deep, go through it all the time, and you'll find your answers. But we want them to learn computer science, algorithms.
I would just add one thing. I totally agree. In my project, I don't tell them what to use. And they ask me back, should we use here 2 classes, 4 classes? Should we use here inheritance? And I'm telling them, I don't know. It depends on your solution. It might be that inheritance would fit there or not. I can't tell you without seeing your entire design, which is yours. So they need to think, and in many cases, the decision is not only what to use, is also what not to use, which is very important. So they learn a lot of things, and they need to understand that they should not use all of them. Like we had here talk about the longest C++ line of code. No, they don't need to use that one.
Okay, so a subject we cannot avoid is the subject of grading. So can you share some ideas? How do you grade your students? Final exam, midterm exam, project, homework?
We think that the most important thing in the course is programming. So we try to concentrate on that. And we give every 2 weeks some kind of project, of exercise. Sometimes it's a whole project from the beginning to the end, not just a very special thing to exercise, and then we have a final project in the end of the semester, each semester.
They do it in pairs?
Even more,
Even
3, 4 students. It's always a game at each semester. The first game at semester A is a game that we are telling them. We are defining it. And the next semester they choose it, they pick it, they do everything from the beginning to the end. And also we have an exam. It's
Can't avoid the exam.
we can't avoid it.
Right.
What we have is we have exercises that we give them once a week on the latest features that have been learned. That's in the 2 courses. In one of them, it's 20% of the grade, and the other one it's just 30, and the rest is the exam. But they all know when we pump it into them again and again that whoever does not do the assignments just will not pass the exam. You have to pass the exam in order to pass the course. So even though the grading on the exercises is lower percentage than the exam, they have to do, I think they have to do the exercises in order to pass the exam. In these 2 courses, we don't have a project. In the data structures course, there's kind of a project that like takes the exercises and builds them one on top of each other towards this along the semester. There have been thoughts about a midterm exam, but we have to find a way of grading these exams that will make it reasonable for us as lecturers. With so many students, it won't take up a whole week to check.
You can use multiple choice questions.
Yeah, but it's not fair on them. That doesn't really, I don't know, whatever. It's another discussion.
Yeah,
we have to.
That's true.
For grading the exercises? We do it as grading the exams. When they hand in exams, we have in Moodle, we have a מה? כן, כן, אז אני עונה לו. In Moodle, we have an automatic program that grades the exercises, but we don't do it for the exams. For the exams, they write it in, and then we have to sit for hours and try to understand what they meant when they wrote their code. So apart from, even if we have 80% multiple choice questions, we still.
So as said before, I have a multiple choice questions exam. It works perfectly, much less work for me. And I do see that grades distribute nicely. I mean, it seems okay. And the questions are hard. And there is the rolling exercise. And one very important thing, I prepare a new exercise every semester and a new exam every term. Otherwise, it's a refactoring exercise for them. A total new one because you want to see their own code and you want to see their own exam.
Yeah, I know. Three quick comments. One, our cohorts are about 500, over 500 students now per semester. So the marking aspect that Adina mentioned is a very critical aspect. Forget about the learning of the student, the lecturer also, or the team of lecturers, is it's a very important factor. But over and above that, I firmly believe, and here I don't get total agreement with everybody, in formative evaluation. The summative evaluation is formative evaluation. It's very critical, important for students to get timely feedback. And I want the student to, through the process that he's learning, to do things, get feedback, and continue. Summative, okay, at the end, okay, let's see, write a program, do this or do that. But it's, especially with our type of new students now, it's important for them to all the time to get constant feedback, and they learn much better. I think the performance would be, in the end, much better that way. But how much formative can you do? Again, how can you mark all these exercises, even with automatic thing? But that automatic is already incorrect. I want to look at the student's code and comment. So, okay, the use cases works. Okay, he gets his 80, whatever. But I want to see how he writes it. I want to see these things, and I want him to get feedback. He needs that feedback. And we have a problem, it's logistic problems, but on the theoretical basis, they should be having all the time formative evaluation, which might be in the end only 10 or 20% of the final mark. It doesn't have to be because the learning. Okay, let's look at the end. That's the summative evaluation at the end of the course. But don't forget the formative aspect. I think it's critical.
Okay, our time is almost up, so I finally want to hear your opinion. How do you see C++ within 10 years from now? Live and kicking, or replaced by other?
My answer is?
Your answer is?
Ask the AI.
Okay.
I think AI will wait a bit. And I think the conference, in a way, gives the answer. We had here more than 300 people for C++. And I think Rust brings less people. I don't know if there is a Rust conference around. Didn't hear about Go conference. They will be, okay, but still not. And C++ is there because of legacy code, because of new code, new projects. So I think it is live and kicking, will stay with us for a while.
Yeah, use the industry.
I think that C++ will stay with us. There is a possibility of a successor to C++, which is called D, but it's not well known enough. So maybe it will not collect the critical mass to become dominating or, but I tried to add D in the course of programming languages to add some aspects of D. I think they took it out. And anyway, I think that C++ will not be everywhere. And I want to quote Bjorn Straustrup that said in one of his interviews, he said, at some conference, a system administrator approached me and said, Mr. Straustrup or something like that, I want you to know that I hate C++ and we use it only when we have no other choice. And Bjorn Straustrup said, thank you very much.
I have no idea, but I hope so. And I also hope that I'll be able to teach it.
I have no idea,
Okay,
but I
thank
like
you.
it.
Thank you very much, all the participants.